For example 1, for my review, looking at exponent properties, when you have a common base, you can take the exponents and you can add them. So we're going to do the 6 plus 2 gives me b to the 8th. For number 2, we are going to distribute the 7x squared to both terms inside the parentheses. So 7 times 6 is 42, and x to the second times x to the first would be x to the third. And for the 5, right, we're going to go 5 times 7x. Well, 5 times 7 is 35, x squared. For 3, combining like terms, looking here, I have x squareds. So I will do negative 2x squared plus 3x squared gives me a positive x squared. And then for the x terms, I have 4x minus 7x is negative 3x. And 10 minus 15 is negative 5. Moving on to the next 3. More combining like terms here in number 4. Do need to pay attention to this x squared term because there is no x squared in my second polynomial there. So I need to remember that there's a 0x squared here, especially if you're going to use vertical format and stack those up so that everything gets lined up appropriately. Combining like terms with subtraction, I have 8x to the third minus 3x to the third gives me 5x to the third. And then the negative 7x squared minus 0x squared is negative 7x squared. Looking at the x's, right here I have 4x minus a 10x would be negative 6x. And then negative 11 minus a negative 2, so I have that double negative there on the 2. So negative 11 plus 2 would be negative 9. For number 5, we are going to look at each part of the numerator and the denominator to figure out how we can best simplify this. So if I am looking at the 5, the negative 5, and the 25, right, they're both divisible by 5. Right, so that's going to be the same as negative 1/5. Right, so I can write that down. And then simplifying each part then from there, I have a to the 4th over a to the 10th. That's going to give me a to the negative 6. Right, I'm going to subtract those exponents. 4 minus 10 is negative 6. So that a term is going to go below the fraction bar, right? Negative exponents go below the fraction bar. For my b, change my color up here real quick. For b, I'm going to have b over b to the 4th. So the 1 minus 4 is going to give me b to the negative 3. So that b is going to go below the fraction bar as well. B to the 3rd below the fraction bar. And for c, c to the 8 over c, which would really be c to the 1, gives me c to the 7. Right, so there is my answer. I don't really need the 1 in the numerator. I do need the negative, though. For 6, I am going to divide both the 15x and the negative 21 by 3. So 15x divided by 3 would be 5x, and the negative 21 divided by 3 would be negative 7. For number 7, one of the more intimidating problems on the review. So I am going to start by taking this 8x and multiplying them all by, multiplying all the terms in the first set of parentheses by 8x. Right, so the 8x times 3x squared, 8 times 3 is 24, and then x squared times x is x to the 3rd. 2x times 8x is positive 16x squared. And then negative 9 times 8x would be negative 72x. Coming back through then, I'm going to come back through with a negative 1, multiplying all three terms again by negative 1. The nice thing about multiplying by a negative 1, all I'm really doing is flipping all my signs. And then just a combine like terms to finish it out. If you do things right, your first term won't have anything to combine with, and your last term will also not have anything to combine with. So looking for x squareds, 16x squared minus 3x squared is plus 13x squared. And negative 72x minus 2x would be negative 74x. And then plus the 9. Looking at dividing polynomials, the first thing we always need to check is if all of the terms needed are shown in the problem. So by that I mean that, right, I'm looking at exponents. So I have an x to the second power, an x to the first power here, even though it's not explicitly written, and then a constant. So in problem 8, I do have all of my exponents represented. So I'm going to model one of these with long division, and I'll model one of these with synthetic. Let's do long division for number 8. So I'm going to start by writing the problem in the form that I need it. Right, so my divisor, x minus 3 out here. 2x squared minus 5x minus 3 goes underneath that bracket. So because I am dividing by a binomial, a two-term polynomial, I am going to start this problem right here. Just like if we're dividing by a two-digit number in long division, we start over 2 places from the left. I'm going to follow that same model that I use with long division of divide, multiply, subtract, and then bring down. So I am going to start right here by dividing 2x by just x. In this long division method, that's the only division we do is these first terms by x. So 2x, this is a 2x squared. 2x squared divided by x would be 2x, right? 2x squared divided by x, right? That would be 2x. I then come through and I multiply. I'm in this multiply step now. I multiply both terms in my divisor by 2x. So 2x times x is 2x squared, and 2x times negative 3 is negative 6. So I'm ready to move into the subtraction step now. Right? So I'm going to subtract here. 2x squared minus 2x squared is 0x squared. Right? So I've been able to cancel out these terms. And then negative 5x minus a negative 6x, so that double negative makes positive. So negative 5x plus 6x gives me a positive 1x. I'm now ready to bring down. I bring down my next term, which is a subtract 3. So now I am going to divide right here, x divided by x. And that would be equal to 1. It's a positive 1, so I'm going to write down plus 1. And I am ready to multiply again. X times 1 is x. Negative 3 times 1 is negative 3. And I am now ready to subtract. I get a 0 here, right, because it's the two negatives make a positive. So I would get 0. So my answer here, I have a remainder of 0. My answer is 2x plus 1. For number 9, I am going to model some synthetic division here. So let's set up that problem. For synthetic division, we make a upside down division sign, and it's kind of stretched out. And then I am going to write just the coefficients. So the 2 from 2x to the third. And then I look, there's no x squared term, so I really have 0x squared. And a very common mistake would be to skip over that 0. It's important. The negative x would be a -1 and -7. Okay? With synthetic division, we don't have a divisor. We have what is called a k-value. And that k-value comes from the divisor here. It is the opposite of the constant. So my constant here is a +3. So my k-value is going to be the opposite of that with a -3. Now that we have the setup done, getting into the process of synthetic division, the first step is to just bring down that leading coefficient of 2. From there, we're going to get into a repeating pattern of multiplying what we just brought down and by the k-value and then addition, right? So I'm going to multiply the 2 that I brought down times the k-value here in the box of -3, and that's going to go right here of -6. I am then going to add, going down in this column right here, the 0 and the -6. I'm going to add down the 0 -6 would be -6. Then I'm going to go back to multiply the -6 by the k-value, and I get a positive 18. And I'm going to add down again. -1 plus 18 is 17. And one more cycle through. I have -3 times 17, -51. Just grab a calculator on that if you need to. And then one last adding of -7 and -51, -58. Okay, this 2, -6, 17, and -58, they are the coefficients that I need for my solution. So notice in this problem we started here with x to the third, and I'm going to start passing out the variable part of my solution, and I'm going to drop the exponent by 1, which makes sense because it's x to the third divided by this x right here. Right, so x to the third divided by x would be x squared. And then I would have x. And then the 17 is my constant. So I'm going to put a plus 17. And then the -58 is really my remainder. So I'm going to make that into a fraction, and I'll put the x plus 3 as my divisor, or my denominator, sorry. Right, so my solution there would be 2x squared minus 6x plus 17, and then plus 3, the remainder part, plus -58 over x plus 3. For numbers 10 and 11, we're asked to substitute into the function, find p of 6 for each function. Function notation, right? The p is the name of the function, and the 6 is our x value. So for number 10, right, we're using that function that they provided for us, and we're subbing in a 6 for x. Right? One way you could do this is to type the function into y equals on your calculator, go to your table and scroll to whatever x value they gave. Right, so for this one it would be 6. You could also just do the math, right? We get 5 minus 24 for an answer of -19. For 11, we're asked to find p of 6 again of this new function. So 2 times 6 squared minus 3 times 6 plus 17. Not 17, plus 7. So just using some order of operations here, right? 6 squared is 36. I can do this multiplication step. And I get 2 times 36 is 72. 72 minus 18 plus 7, and that would be 61. End behavior here on number 12. End behavior, we're looking at what happens to our graph, our line, our output as x approaches negative infinity and positive infinity. So looking here, as x approaches negative infinity, that means as our x value continues to get smaller and smaller, what is happening to our output or our f of x, right? Y is headed down and it's now going to rebound back. So in this case, we'd be headed to negative infinity. And then here, as x approaches positive infinity, as x gets bigger and bigger, what is happening to our output? Well, it is headed up, and it would be to infinity or positive infinity. I see a lot of students, they just write a negative or a positive on that line, and you need to make sure that you're putting the infinity part on there. Looking at Pascal's triangle, Pascal's triangle is that patterning, right, where we start with a 1, and then we have 2 1s, and then 1 2 1, right? And we need to remember in Pascal's triangle that first 1 by itself, we denote that as row 0, and then the 1 1 is row 1, and then row 2, and so on. The outer layers of Pascal's triangle are very predictable. It always starts with a 1 and then the row number, right? We see the 1, 2, 3, 4 on diagonal, one on the outside edge as well. What is really happening with Pascal's triangle is we add those two values above to give us our value below, right? So 1 plus 3 equals 4. Here I can go 3 plus 3 equals 6. It works up here as well, right? What's 1 plus nothing, right? 1 plus 0 is 1. Right here, 2 plus 1 is 3. So we can continue that on, that pattern on for Pascal's triangle. 1, 5, 10, 10, 5, 1, and then 1, 6, 15, 20, 15, 6, 1. Right, so that would be our 6th row of Pascal's triangle. To find the first 3 terms of the 10th row, well, we know that the first term is always 1, and the second term is always our row number. The third term is the one that's a little bit more work. And instead of building the entire triangle, right, all we really need to do is work on these first 3 terms. So the 1, 7. Well, 6 plus 15 is 21 for the third term in row 7. And then 1, 8, 28. 1, 9, 36. And then the 10th row then would be 1, 10, 45. So 45 is that other term we are missing. So there's no need to fill out all this space over here because we don't need them. So the whole point of Pascal's triangle for what we are doing in Algebra 2 is looking at expanding a binomial expansion. So because we have x plus y to the 4th, we are going to look at the 4th row of Pascal's triangle. And those numbers are going to be the coefficients for my expanded form of x plus y to the 4th power. Right, so I can write those down, the 1, 4, 6, 4, 1, and I went ahead and put some plus signs in there because that's going to just kind of help keep me organized. The other part of the binomial expansion is we have to pass out the x's and the y's from our original binomial. So they're all going to have an x with different exponents. And we're going to actually start at the 4 because this whole thing is to the fourth power, we decrease our exponents by 1 all the way across. We come back through with the y, and we're going to go the other way. We're going to start at 0 and go up to 4. And if you notice, as I'm going across, the exponents of the two variables add to 4, the same 4 that we have here, all the way across. So if I was going to the fifth row, I would use to the fifth power, I would use the fifth row of Pascal's triangle, and then I would make sure that I start at 5 in my exponents and work down to 0. The last step then would be to do any simplifying that we can, right? Anything to the 0 power, that 0 power property, right? So here, this y to the 0, anything to the 0 is really a 1. So this first term is really 1 times x to the 4th times 1, which we could simplify as x to the 4th. And then I have 4 times y, or x to the 3rd, y to the 1st. We don't normally write down a to the 1st power. So this last cleanup step, especially when you have two variables in your original binomial, is really just removing 1s. X to the 1st, well, I'm not going to write down the 1 because it's implied anyhow. And then in this last term, it's 1 times y to the 4th, and I just take the 1s out again. So my solution would be here. Big part of this quiz is paying attention to details, watching for double negatives, all your sign changes, and things like that. So those are the common mistakes people will make. Best of luck on your first quiz over Chapter 4.